Okay, looks like we're live here. I'm Peter Baumgartner, and this is Yan Malay. We're broadcasting here on Google Hangouts, and we also have a chat available on IRC if you're on the Freenode network. It's Lincoln Loop is the channel, and if you happen to be watching someplace else, you can go to highperformancedjango.com/live, and there's a chat widget there as well. So today we're going to be talking kind of about our book, High Performance Django, which we released recently, and answering any questions that people might have about it. It's the focus of the book is basically how to make Django websites fast and get them to scale to lots and lots of users, and doing that efficiently. So we've got a few questions already on Reddit here that I'm going to start poking through, and anybody who's here in IRC, let us know, say hi, and also we'll get to your questions if you have any. So Yan, the highest rated question on Reddit was asking about Americ's template refactor that he just funded on Indiegogo. Americ's a Django core developer, and he's basically working on, or just funded a project to bring Django templates out as a standalone library, so they could be used outside of Django without mucking with Django settings, and also bringing, kind of making Jinja 2 templates a first-class citizen. So Jan, what are your thoughts on that?
This is an interesting project, and there is still 12 hours to fund it. So if there is anyone interested in making this happen, you can still go on Indiegogo and help Emmerich to make this through. All this being said, I have seen recently that Django template being slow has become something that people mention a lot, and it's something that actually it has never been the bottleneck on the project I've been involved on. And I was wondering why this is the case, like why is it becoming such a predominant discussion, where in fact it's something that for us have never been like the major bottleneck.
Yes, so on some of the larger sites we work on, we kind of try to work it within a response time block, and Jan, I think that's usually we try to get something around maybe 200 milliseconds for a backend response. Is that about right?
Yeah, I think it's something that might depend based on the customer request, but between 100 millisecond and 200 millisecond average, you're already in a very fast place, acknowledging that your page might take
And
7 seconds
the
to build.
breakdown on those, how much of that do you usually see as Python work versus work in the database or someplace else?
It really depends on the project and where you are in the phase of optimizing your stack. But on a project that I have fresh in my mind, like you would build the average response in around 150 milliseconds, and you will probably spend half of this in Python, and then the other half will be shared between the database, the cache, and some smallest places. So it's Python work will take, part of it will be the template. But inside what is written, like if people use New Relic to actually follow the breakdown and know what it is, like there is a template category in New Relic, but it doesn't only count for like the template work, it's also count for the work you are doing in the template, which
In the template tags?
pardon me?
In the template tags?
Yeah, that might be one, and it might be like you're doing plenty of thing in your template. So it's really like this trade-off of how you account for it and how much gain you can get by switching from Django template to Jinja, and what you have to lose for doing this. And
Right.
especially when you are working on an existing piece of application, it's you might have easier performance gain to get elsewhere,
Yeah.
which for us has been mostly the case.
Yeah. So I mean, even if you're spending, on the high end, 100 milliseconds rendering templates, and you can cut that in half. That's a nice performance win, but it's
Yeah,
not uncommon to see people spend 200 or 300 milliseconds just in their database, if not more.
yeah, and also you have to balance this with the fact that when you are building the page in your browser, it might take 5 to 10 seconds to actually build the page. So like maybe removing an image from your page will get you a better performance boost than just doing something in the template. So it's really a trade-off, and it's not valid to say that this is penalizing Django, because if you don't want to spend time in the template, you can also not use it and just return raw JSON or something else. Like it's not that you have to use it.
Right.
And again, there is plenty of things you can make to. So Django template, I will never say it's fast. Like they are slow, and there is plenty of benchmarks that show that they are not the fastest template implementation in the Python world. But there is plenty of things you can do in and around your template to actually make them like fast enough, as some people like to say. The first one is actually use the cache loader. There is a template cache loader that cache in memory the templates that avoid to read from disk every time you want to read the template. This is usually a very good performance boost that you should use in production. The other one is actually don't go too crazy with template inheritance. Like don't go with this very long of 20 chain of template inheritance, include, and with loops that include templates. This is not cheap. The other one, which is actually very interesting and covered in the book, is using this pattern of doing Russian cache door, which lets you cache HTML fragment in HTML fragment, and by using properly set cache key, you can invalidate them fairly easily without getting into a nightmare of getting your page reloading properly. Maybe we want to say a few words around this technique bit.
Yeah, so I think the place I see that being used a lot in our code is, you have a template that's rendering a list of items, and you're going to do a very short-lived cache template around the entire for loop. So, maybe, well, it really depends on your use case. Maybe it's a couple minutes. And then on each item, you're going to do a longer cache, and that might be 15 minutes or a half hour or something like that. So on every iteration, or every time you render this template, a lot of times you're going to skip the for loop altogether, which is going to skip loading all the extra templates that you needed to load to generate that content. And if your for loop cache expires, you're still going to have a whole lot of your content cached inside it. So you might regenerate one new item at the top of your for loop. You put a new blog post in or something like that, but the rest of the items get pulled out of cache. So that can help a lot. And then you can also use key-based invalidation. So setting your cache keys based on the date of an object or something like that. So if a last updated date. So if you update the object in the database, the old cache is going to be invalid, and you'll get fresh content. So that helps a lot. Not serving stale content, but the content that is old and is never going to change, you can cache for a really long time.
Yeah, this is very interesting, but it might sound like we are adding work on our Django stack rather than removing. But it's important to keep in mind that when you are handling thousands of requests per minute, even if you are caching for 1 minute, like this is 1,000 times you don't have to do all this dance, and you will just, for all the requests you are getting through, you will just get them from a very high level in your template hierarchy. So you will not have to rebuild everything. And this is just for 1 minute. But if you make this 10 minutes, it's 10 times bigger. And this also helps you to remove some pressure from your database, because often the dynamic content coming in your template is coming from your database. And by using this tactic, you are going to avoid eating your database too hard, and your page is going to render pretty fast because most of it is coming from cache key. So in the case of the article list you described, you will not even have to access the article because you have the list built, and you will just go and render this block of list with the thumbnail and everything, and you don't have to go for the article, retrieve the thumbnail, retrieve the image, build the thumbnail, and all this will be just done, and you can use this for 10, 20, like depending on how long you want or how fresh you want your content to be.
Yeah. So I think the original question was, are we going to look into switching over to Jinja templates once Americ's work lands? My thought is, we haven't, like Jan said, we haven't had a major need for it yet, but if it's faster and it doesn't create a whole lot of development overhead, then I don't see why we wouldn't look into it or start using it.
Yeah, especially for greenfield project when you don't have legacy code base to handle. I think it's going to be much more difficult to mix and match the template when you are along in inheritance strategy. Like it's either your site will be in Jinja, or at least a section of your site will be using Jinja for everything, or nothing. I'm not sure it's going to be. I'm going to use for my base template Django, and for rendering this left rail Jinja, and maybe this one in Mako in the same project. You might have services that use different rendering engine, but I think it's going to be you pick one, like you pick the one you feel good with, and when you are reusable application, if you have an important part of your applications that ship with Django template, you might not want to rewrite them. Like, I'm not sure that would be a good use of the time if they are fast enough. Like the real question is on the typical website where we are rendering the page in 100 something millisecond, how much win are we going to get by just flipping the template? Like if we imagine that we rewrite everything, is it going to be 10 millisecond, 20 millisecond, or is it going to be 90 millisecond? But knowing what we are doing as calculation, I'm pretty convinced that I would be really, really surprised if it's 90 millisecond. And so the question will be, for this additional boost, like what is going to be the cost, and what will I have to leave, like to trade? Right.
Yeah, I think we're in a position where we work on a lot. We're primarily working on projects for clients, and we're on tight budgets and timelines and all that. So we're really trying to apply the kind of the 80-20 principle. What's the 20% of the effort that gets us 80% of the performance gains? So yeah, going through a project and rewriting all the templates to get a 50 millisecond gain, isn't probably going to be beneficial for us, or it's probably not going to be the best use of our time.
Yeah. So I'm pretty sure that we'll get a much better performance boost by using like updating AZ thumbnail to use the latest version that enable you to use some PNG optimizer to compress the image size that would reduce like significantly the amount of data you need to transfer. On the wire, this will be a much better performance boost from an end user perspective. So it's really going to be like this trade-off as you are describing. But all this being said, as you mentioned, if we start a fresh project like and it proved to be much faster and we don't need to trade something important for us, it will make total sense. Like something that is coming to my mind is template tag. Like there is libraries that are shipping with template tag. So AZ thumbnail is one. I will need to rewrite the template tag, or I will need to write the equivalent or call my function, and it's going to be like this is starting to add some cognitive overhead and might also add some development overhead.
Yeah, I'm interested to see how he implements that. I wonder if there will be some, kind of easy backwards compatibility with existing template tags that would save a lot.
Yeah, it's very exciting, and Emmerich already carry over some huge project like the time zones, the transaction recently. So I'm fairly sure that this is going to be delivered in 1.8.
Yes.
He has some very solid track of record.
Yeah. Yeah, I don't know. I think it's interesting. I hear a lot of people talk about, it like templates are one layer and like ORM, people say, oh, Django's too slow. It doesn't, you have to get much performance, you have to swap out all these pieces. And we've built a lot of sites that are really, really high traffic and pretty fast. And I can't think of a time where we've had to replace some stock part of Django with something else. I think the cache framework is maybe one piece that we've, I wouldn't say replaced, but maybe extended a little. But
yes.
Yeah, I mean, we've never had the need to, look at SQL Alchemy versus, the Django ORM or something like that. I think it works extremely well, and I think the people that are looking at swapping out those parts are either working on a scale that, 99.9% of the developers are never going to see, or, they're just optimizing prematurely.
Yeah, it might also be an area they are confident with and they prefer the tool, and yeah. I can also hear this. And someone actually on Reddit asked about the ORM, and he says that the ORM is chatty. And I was, on one hand, I understand that it's like the way you build the query, and especially in the template, like you just use dotted notation to traverse the relation, and then you add this for loop because you have this a set, and then you traverse again a relation, and then you add another for loop, and you end up with like this hundred of queries, many of them being fairly similar, just changing an ID or. And this is actually very easy to write, and to end up in that situation. Also, it's not because you're not writing SQL that you shouldn't, in my opinion, look at the SQL that is generated. Like when you are developing your site, you should keep an eye on what query am I triggering on this content. How long are they taking? Which query is the longest one? Do I see places where I do n+1 query to fetch content? Like all this is things you should keep an eye on, and also and try to optimize this and avoid like loading. The ORM is coming with plenty of tool to help you there. Maybe you want to say a few words around this.
Yeah, I think one way you can get really chatty is, you build your views and you maybe optimize your views, and then somebody comes in and changes the template and, drills down 2 relations deep, triggers 100 more queries without, there's no reason why somebody working in the template at the template layer would expect that to happen. If they, if you think of it like it's just an object and, oh, I want to get to this attribute down here. So I understand that it is easy to make a page with 1,000 queries on it without, doing anything too stupid. But between select related and prefetch related, it's super easy to get those down. So I think our typical process is first you just build the thing, get it working. Make sure you've got the data you want and your views structured the way you want. And then if you're working on a site that is going to get a lot of traffic right off the bat, pop open Django debug toolbar or use Django dev server or something that's going to show you the SQL queries and hit some of your big pages. Make sure you have some somewhat real data in your database so you can see what's happening. And if you've got a page that's got more than 50 queries on it, just trace back to the view or your template tags and see, oh, I'm pulling a team object and then I need all the members for that team, so I need to add in a prefetch related here. That's super easy to fix that way, and you can take a page from 500 queries down to 50 within a couple minutes sometimes. So I think it can be chatty if you're not paying attention, but once you're paying attention, it's really easy to optimize it. And then I think if you're on a site that's is not going to get super heavy traffic, putting it out live and having something like New Relic that you can watch and just say, oh gosh, this one view is spending a ton of time in the database. Let's go in and do some optimization and just sprinkling those in is pretty easy. And I think the 1.7 adds some new functionality to prefetch. It used to be that prefetch could only fetch all of the query set you wanted. So if in this team members example, you could only prefetch all of the members for a team. But now I think you can use a special prefetch class to narrow that query down. So you can say, give me only the members that are prefetch only the members that are admins, and then you've basically cached that or done one query for it instead of 20 queries. So yeah, I think it's easy to generate a lot of SQL queries, but it's also really easy to optimize it back down. So that's not a major concern, I don't think.
One tool that I like to, it's not even a tool, is actually with the logging configuration, you can also print the SQL that are generated as you use on the local development. And I usually turn this on for local development, so even if I don't have the debug toolbar, or if I'm working on an API or like for various reasons, I found it like very convenient to have it directly logged in the console also. And in addition, it's something that you touch, but this is a place where an application tends to get some weight over the course of months or years that it's getting in production, because it's often like we have this ticket that get in and it's like this 2-line fix or this template change and changing slightly the attribute you want to display, and it might be a place where it's even the template and the view and the object that are passed have been super optimized, where you defer loading fields because you don't need them. But during the course of the project, it's this start to get added again, and like the way you build the query never change, and this tend to actually trigger the fact that you are triggering queries that you used to not trigger, and the people that are doing the template change, if they don't trust back or pay special attention to this, it's very difficult to catch. So it's why I think it's once you have your application in production and it's all running and you are in maintenance mode and doing enhancement, it's very, very important to keep an eye on the performance and keep an eye on the improvement or degradation. Like on a daily basis, you should go and look at your your traffic pattern and look at the average time you are spending in each view, and on your application, this is number you should know. Like you see them and you will know that, oh, like there is something wrong. Like we just deploy something and we are spending 20 milliseconds more or 50 milliseconds more, or the database load used to be 20% and it's now like 33%. There is something deeply alarming in this. Even if the traffic continues to flow, it's not like taking down on your site yet. But if you do this multiple times, it will go from an application which is very well tuned, and in the course of a few months, you will get to an application which start to get slower and slower and use more resources. And when you are in that stage, it's actually very difficult to remove all this, because it's not like you cannot find a commit that actually did this. Like, it's plenty of very small iterative mistakes that have been added on top of each other that end up in that situation. So you need to rework from top to bottom, and this is time consuming.
Yeah, I think being able to have a graph of your response times or your database load or anything like that, and checking it, at least weekly to see if there's any, big jumps up or just a general trend up, and catching that stuff early rather than waiting until it's, really problematic.
Yeah, and if you have such graphs, like looking at it before and after the deploy is is a good idea to catch like the whoops, forgot this one before it gets in your arm.
Definitely. So one of the other questions on that one about the chatty database was about model complexity and keeping model complexity down. What do you think about that? Do you think it's important? Do you think it's more important that your models match your mental model of the app, or are kind of optimized for the query patterns?
Taking aside the denormalization that you might want to do for optimization, something that Django make fairly easy is to build the model structure in a way that is fairly close to what the people doing the business talk about, because this is what is going to be exposed in places like the admin, and it's important for the users to be able to find objects that make sense to their activity in a way that is sensible to them. And if you optimize everything for the raw query performance, you might end up in a situation where your query will be fast, but your users will be you will move down like the complexity to the end users, which is usually not where you want to move the complexity. It's they need to have the object that they are like almost having the name they call it in the office. Like, are you working on the article, the product, the like whatever the business object is? But it needs to be similar. And in fact, I don't really think that this is something that Django is related to. It's you will find it in any language or framework that you are going to use. Like, it's part of going from the business object of a customer to something that you can represent and that the computer can understand and that you can model.
Right.
So
I'm of the same approach. I think you want to start optimizing for productivity rather than optimizing for speed or something like that. So write code that makes sense, and write models that make sense to you as a developer, make sense to your users, and if down the road you've done every other optimization and you find you have to tweak the way your data's structured to make it faster, consider it then, but I wouldn't consider it early on in a project.
Something that I find very important, and it's kind of a nitpick of mine. I'm really focused on this, is the fact that the name of the object in the code are the same than the ones that are used by the people, like the customers. Because what's happened if you don't have this connection, especially when you handle code that is going to live for quite some time, like the developer goes and you get in as a new person, and you just arrived and your customers start talking to you. You can maintain this code base. Yes, sure, I can. It's in Django, like it's using this technology. Are you familiar with this? Yes, we are. And he start talking to you, but he's using his word. And then you need to go like deep in the code and trying to match like, so he's calling this and not like this name, and in the code it's called another name, and you need to build like this Rosetta Stone to establish the relationship between the two, and this is actually very confusing, and it makes things much harder than they could be if the naming was done properly.
Yeah, I think people are tend to be really afraid to rename stuff, but it's, you know, if you have a test suite and you have a way to do global find and replace like any good text editor does, it's better to tackle that stuff early on, because just like you said, somebody's going to come into the project without all that history in their head and what's going on.
Yeah, it's hard.
Let's see. So, okay. How about the Tech Empower benchmark, which kind of goes along with another question, basically saying, why would I use Django when Node and Go are faster? So, yeah, and you actually looked a little bit into, I'm familiar with the Tech Empower benchmark. I'll copy a link for it in the IRC, but you actually looked into what's the code, what is that running on each different framework?
So there is a bunch of tests that are done in that framework, and I would say framework of tests of benchmarks. There are specs, and people contribute pull requests for each, like the framework they like, and you can improve the one you are working with if you want to see it shine and become the first one. Also, going up to the top is now starting to be really hard. So there are a few tasks. One is about almost building a JSON a JSON string and sending over HTTP. Another one is about asking requests to a database, which is I think generating a number and sending it back. And it's very small. I wouldn't say almost unit test, but it's fairly self-contained test. And of course, as you would expect, Go, C, some very low-level languages are going to shine in that test, because the goal is to make as many requests as you can with the resources that are available, and they use very few resources, and they are very efficient in the way they handle it. And in those tests, if we depending on the server, the size of the server, like which one perform best is different. So I'm looking at the first one, which is I7, and this test, like Go, is reaching the first position, and they call it like 100% for the first one. And if you scroll down, like since we are talking about Python languages, you are around like below the 10%. Like the fastest one, I think, is in Python word is Flask on PyPy, which is like right on the 99% of the top one, which is Go. And then as you go down, you would go Flask without PyPy, and this one is 2% less. It's actually interesting to see like PyPy speed up by 10%, by 2%. And then going down the stack, you will finally find Django, which is around 4.3%. But again, like the question is, So yes, Django is way slower than low-level implementation like the one you can make in Go. But the question is, for the kind of application we are building, which is large application with a very large surface of endpoint and building dynamic content on something like a newspaper, to take an example, where you have to address on one end the building the public website and also the back-end website. You are going to be having to trade two things, like the budget to serve a response time fast enough and the budget to actually build the thing. And the compromise you are going to make is, I can maybe serve it faster by using something like Go, or there is another one which is actually interesting. It's based on Nginx and Lua and Ready, and it's what was the name of that one? I saw it was
Resty, Open Resty.
Resty, yes, that's the one. So you can use this thing, sure, and they are going to be faster at having raw responses. The question is, how are you going to balance building this complex application with a very large surface with the budget that you have at your disposal? And I firmly believe that it's going to take you way more time to build this kind of application with this low-level framework than you are going to spend using something much higher level than Django. And part of the book is actually explaining you which kind of tool set you have at your disposal to make your application build with something which is not the fastest thing on earth, like Django, serve this application very fast by actually not engaging the Django stack, but by serving it from the different level of cache.
Right. Yeah. I think it's. I agree. I mean, you could write stuff really quick. That was really fast in assembly, but there's a reason we use Python. And I think the kind of common thing you hear is it's fast enough. I don't know. I think you're not going to build an entire CMS in Go. You could, but it's going to be painful and it's going to take a long time. And the win you get at the end is probably not going to be worth it, because you're not going to be able to iterate on features as quickly, because you don't have this huge standard library. And I think anybody who does asynchronous programming will tell you it's more difficult than standard kind of blocking type programming that you do in a language like Python. You have a lot more to think about. It's a lot harder to kind of wrap your head around. It doesn't matter if you're using callbacks or yield statements or Go routines. It's just it's a harder thing to kind of wrap your head around, and it's easier to have bugs that are kind of non-trivial to work out. But that being said, I think there's really great places in the stack for languages like these.
Yeah, and it's interesting. Like, to take an example, a very concrete one is BotBot, the IRC logger we are building. Part of the stack is the logger itself is built in Go, and this was a really perfect match for the language. It's really low level. It's network oriented. It's a service. But the web application serving the logs is actually a Django application, and we have Go in the place, so we could have written the logger, like the web application, in Go too. But like, the trade-off was, for us, it was much faster to actually build it in Django and focus our time and energy on writing the low-level important thing in Go, and trying to make this part work, and have this higher level languages at our disposal to write the web application in a much faster way. And of course, as you are scaling, and this reminds me, I think it's Discuss that put out some blog posts around about how they are moving some pieces of their infrastructure to go. And this might be an optimization. Like as you are scaling and growing, you might find out that one endpoint of your total surface of your application is actually start to be your bottleneck, and you might want to optimize that one. And you might get a huge benefits from rewriting these pieces in a much lower level languages that is much faster, because you can really get things like in almost a 10x improvement. So it's huge. Like there is I will not neglect this, but I think as part of the compromise between the budget you have and building all the feature you want, all these tools have their place, and you should really pick one where it's really well suited. And you shouldn't like block yourself to not use Django because it might not be fast enough. The point of the book is to show you that there is plenty of tool at your disposal to make it fast enough for high performance website. And the truth is, most of the pages that you are going to serve on a day is not going to be built completely by your application. Like many pages will just be served from one level of the cache, or many pieces of the pages will be served from a cache. So it's like the number of pages you are actually really building is a very tiny fraction of the total amount of what you are delivering.
Right. And I'm guessing, if you looked at a varnish cache page on this framework measurement, it's going to beat even the fastest frameworks. You're looking at under 5 milliseconds to return a cache, a full.
Yeah, it's going to be really close. Like it's going to be in the same link than the top level framework, but so the idea is you can use Varnish to actually drag your performance from the 4.3% to a place where it's just to a place where it's not your bottleneck. Like you will get much better performance improvement from a user perspective by working on your images than continue to work on your backend, or by writing on the DOM that you are building in the browser. Like this will be much more significant from a user experience than trying to squeeze few more milliseconds on your backend.
Yeah.
So yeah, they have their place.
Yeah, and I think if you talked to, it's been a while since I've talked to anybody at Discuss, but they're big fans of Go and they're big users of Django. And I think if you ask them, hey, if you were going to rebuild your infrastructure from the ground up today, would you do it all in Go, or would you do it, in Django, or would you use a combination? I'm guessing they would probably say they would still use the combination. They might change some things, but I don't think they would say they would build it all in Go.
And also it really depends on the size of the company. When you are 2 people building a fairly large website, productivity really matter. But when you start to be few hundred to build the same website and maintain it and like squeeze less pieces of performance out of it, it's different. Like it's not the same setup. Like if you have 200 engineers that can rebuild the same application, you might want to do it in Go because you have all this at your disposal. But if you have only 2 people, like performance and pro efficiency really matter.
Right. Yeah, and then there's the saying, servers are cheaper than developers by a long shot. If you can add one more server and handle more traffic or stuff faster, or add a bigger database server and make your code run faster, that's typically going to be way cheaper than having another full-time developer working on a project. It takes a lot of servers to be equal to a full-time developer salary.
Yeah, even on the non-cheap servers that you are getting from Rackspace and Amazon, you can still pay a lot of people.
Okay, so Yeah, if you raise your eyebrows about high performance Django, I think high performance means a lot of things, and you can you can build you can build sites in Django that respond in under 10 milliseconds, with the right setup. So I would say the benchmarks are benchmarks. They're not real world applications, and they're testing stuff in ways that they might not be set up in the real world.
Yeah, it's only one part of the story. We like with this book, we are not claiming that we are having secret ingredients that will make Django be like in the top, like above Go or a Go above all the others. It's not the goal. Like it's not our goal. The goal is to be able to write Django website and to be able to serve them in comparison of any other technology without being pointed as slow.
Yeah, yeah. I don't think your end users are going to notice if it's done right.
No, not at all. And actually, many of the technologies that we are describing is not Python or Django related. They are general purposes web development tool. There is nothing specific to Django.
Right. So kind of this question kind of shoehorns into that one. Well, basically, asking about Node.js and Go, and why would I move back, or when, what's the trade-off? And I think we sort of talked about it, but I think one place where some of these other languages shine is in real-time stuff. So if you're serving basically lots of users with long-running open connections, WebSockets, Socket.io, Sock.js, long polling, whatever. I think some of these other languages shine in that respect. So when we're talking about developer productivity, maybe working with your database and building HTML is much better in Django. But as far as kind of real-time stuff and pushing updates to clients and holding open lots of connections, you can do it in Python, but I don't think it's necessarily as easy or as efficient as using some of these other languages that were really built from the ground up with that in mind.
It's actually a very interesting example because we have first-hand experience with this over the course of a few years. And few years ago, when we built Ginger, or when we laid down the architecture of what Ginger is today, gingerhq.com, we choose Node.js for the WebSocket endpoint. And when we built BotBot, more recently, we started going down against we tried pretty much everything in the Python land, and finally rewrote it in Go, and we are using event source there. And so it's really interesting to see that the landscape changed, and a few years ago we chose to use Node.js, and more recently we choose Go. And every time we try to go with a Python solution and try and decided to pick another one for a reason. I found this interesting. Like it's again a case of each tool has their proper usage, or yeah.
Yeah, definitely. Use the right tool for the job.
Exactly. Yeah, that was the right code.
Let's see. There's a question here. Also, if anybody has questions in IRC, throw them out at us. We're kind of getting close to the end here, but we also don't have a lot of questions left. So, live server test case and testing with Selenium. Anything better? I haven't come across it. I don't know. It's for the amount of Selenium testing we do, it's worked okay for us. Yan, do you have any thoughts there?
No.
Yeah.
No, no, sir. Also, I know that recently you work on getting like the a test environment where you put a machine where you can run your test and tear down the machine at the end.
Right, right. So yeah, I was playing around with Fig, which is Python library that lets you control Docker containers really easily. So you use YAML and you say, I have all these different containers I need to spin up for the service to run. And so, yeah, I was playing around with basically a Selenium Docker instance, or Docker container, which had a fake X server in it and Firefox in it and Selenium in it, and then pushing Selenium test through to that container. I think one of the things that's tough about Selenium is it's just slow. So, because it's actually manipulating a live browser. And I wouldn't say that's as much live server test cases problem, but it's, yeah, there's stuff like Phantom.js, which has some integration with Selenium, but it's not exactly like a real-world browser. But our take has kind of been just let that stuff run on a remote server. Have Jenkins run the tests, and if they take, a half an hour, that's not great, but at least it's not holding you up while you're doing your work. So yeah, I haven't seen anything better. Looks like there's some questions here. Let's see. How about optimizing Django admin performance? That's something we've definitely run into in the past. I think in two areas. One is search gets really, really bad when you have lots and lots of rows and kind of rich, big text blocks that you're searching. Dan, I think you did. Did you do some work on that?
We did customization to search using in Elasticsearch instead of going in the database. So this is definitely speeding up the performances. Also, something that even if it's the admin, you can already get a lot by using the same tactics that you will use on the front end, which is select related, prefetch related. When you are traversing query to build the list, it's places where it's getting you a ton of help. Something that is also helping a lot is the filters on the right-hand bar. Building them dynamically, in some cases, can be fairly expensive, like to group by, on an example, like coming to my mind, an example like bot, you would have all the line in the database, and you would have the command on each line that can be a filter. But this command, so you could group by and get this dynamically from the database. But these commands are actually coming from a spec which is well defined, and we know what are the IRC commands we can have. So there is no reason to build them dynamically. So we just have the list of commands and have a link to filter on them, and that's speeding up like drastically the admin. It doesn't load to it load really fast. So there is this kind of small tactics, and it's not totally true that you cannot cache. Like there is things that get cached, and database also have a cache layer. So it's sure, if your database is a bottleneck, asking anything to the database is going to be slow, but the database should not be the bottleneck. And also one other, which is a big boost, is not counting.
Yeah.
Like to get the number of pages. It's nice to know, but maybe next page is good enough. Like most of the case, you don't actually, like nothing behind page. People say nothing behind page 2 is on Google get ever clicked on. So you can go to that road. So it's small customization. It's exactly the same tactic that you would use on the front end.
Yeah, and I think the admin has actually, people complain that the admin hasn't changed much, but the code underneath it has actually changed a fair amount, and it's a lot easier to make those changes if you need to. You know, say, hey, this admin page loads this query set, and you know, I'm going to add a bunch of select relateds and refresh relateds on it. You can customize the paginator. You can customize filters. So it's a lot of the same technique. You know, going in, looking at the view, looking at what database queries are triggered, and then tracing them back to the place in the code, and you know, sprinkling in some of those things to make it less. And then I think that the query cache is really interesting. It's not something a lot of people seem to be talking about much these days, but there's a few, if you're not familiar with it, it's basically a layer that's kind of sits in between the ORM and the database, and can cache stuff and use key-based invalidation to make sure you're always getting fresh content from the database. But if you're using database tables that don't change frequently, those come from the cache. So there's a few projects out there. Johnny Cache is one we've used in the past, but it's not, with some of the transaction changes in, I think it was 1.6, it's a little on shaky ground. It works, but there's some kind of edge cases you need to be aware of. But there's another one called Django Cache Ops, and yeah, I think there's a couple more. So that might be something to look into if you're doing really complex queries and you can't optimize them, or it's too difficult to optimize them. Sometimes just throwing that in the middle can help a lot on a read-heavy site.
Yeah, and it sounds like very complex to set up, but Johnny Cache is maybe 2 lines in your configuration. You need to add the middleware, and you need to add Johnny Cache in the install apps, and it's about it to get started. So it's really easy to give it a shot and try to see if you get any performance boost. Like, it's not for everyone, but there is some very good usage there. And it can take you very, very far, actually, if you are in that sweet spot.
Yeah.
So it's really interesting. We have another question, Pete.
Yeah, let's do one more and wrap it up. So, minimizing downtime during updates.
I assume that this is related to deploying an update on a live website.
I think so.
You want to minimize downtime. So maybe you want to tell us a word about the strategies that we are applying there.
Sure. So we use uWSGI as our WSGI server. So usually that's there's Nginx out in front or Varnish out in front, and it's proxying back to uWSGI. But most servers have similar functionality, and that's so uWSGI has a reload mechanism, which will gracefully basically kill off workers once they've finished serving requests, and then spin up new workers. So when you use the reload versus like a hard restart, on a hard restart, all your servers go down. There's a short period of time while you're waiting for them to start back up that you're actually dropping requests. So we use reload, and that lets you keep up and running while the server's restarting.
So
go ahead.
So the WSGI process has loaded the code in memory. It's serving the request from that code loaded in memory, while you change the code underneath, and at some point when the deployment is done, you ask him to reload from the new code. So he's finishing to serve the request with the he already has with the code he has in memory. When he don't have any more requests to serve, he start reading the new code and serving the new request with the new code. So you have efficiently taking your new site or your update out without doing an outage.
Yeah, and then I think thinking about your updates and trying not to have breaking changes. You know, if you're going to add or if you're like deleting a row from a table or a column from a table
Yes.
is rarely like something you need to do right away. So deploy the new code that doesn't depend on the row, but maybe hold off on deploying, something that's going to kind of break backwards compatibility immediately. Or, if you have an API that has a certain format and you want to, change the format, like use versioning in your API so your old clients still work and stuff like that. So figuring out a way that you can push changes without actually breaking existing clients or something like that, I think is a good practice as well. And then trying to the other thing you need to consider is maybe you're doing a database migration, and your new code depends on the database migration, but it's a long database migration, and figuring out a way you can do the migration with your old code in place, and then serve your serve your new code that will talk to the new database. So doing maybe multiple deploys.
Multiple deploy, breaking down your deploy into incremental changes that each of them don't break, and you can roll out first the schema changes and the code that use the new schema, and then maybe remove the old pieces. And often also we end up doing data migration. Like in that case, you might have a change in the schema, but you need also to change the data. And this is something that you can actually do in the background while you are not yet using it, but you start copying over things, and then you can do this several times, and at some point you will be in a place where you are rating into places, and then you can cut over and go to the new field, and this is effectively very nice technique.
Yeah, I see more and more people talking about not using Git branches as much for major features, but building your features into production right away. They're just not actually in use. So your code kind of slowly gets into production. You're not breaking anything. All your existing code still works. You're doing changes to your database, but they're not changes that are immediately required. And by the time you get to that point where you need to actually flip the switch to the feature, it's a very small deployment.
Yeah, and it also lets you test it before before the end users. Like you can have some special flags that let you test features that are kind of restricted, not for public use. Right. And this is very, very nice feeling to make sure that it's actually working rather than pushing and praying. It's a very, very nice pattern.
All right. Well, we're approaching an hour, or just over an hour here, so I think we should wrap it up. It's been really fun. I think we're going to try to do this maybe every couple of months. I hope everybody that's watching enjoyed it, and if you guys have any other questions or anything, don't hesitate to email us or get us on Twitter, or our IRC room's always available. And I have to do a quick plug for our book, High Performance Django. It's at highperformancedjango.com. We also have a couple of other products, gingerhq.com, which is our tool for remote teams discussion and communication, and botbot.me, that's our IRC logger. And we also do Django consulting. So if any of you have a company that needs help, or just needs some advice, or needs some extra kind of firepower to build a new feature or a new site or anything like that, get in touch with us. So thanks, Jan, and thanks everybody for coming.
Thank you, Pete.
Bye.